party started. All right, hi everyone, or as we say in America, howdy y'all. I'm Casey Uhlenhout. I'm a program manager on the .NET and Visual Studio team at Microsoft. Specifically on that team, I work on the C# compiler team, working on the C# developer experience in Visual Studio. So today, I'm going to talk to you about what Roslyn is. I'm sure some of you have heard about this Roslyn thing, and you don't really know what it is, so I'm here to crack that open for you. We'll also demo what analyzers are. So a big part of Roslyn is live code analysis, and part of live code analysis are these things called Roslyn analyzers. So I'm going to demo what those are. Then we're going to really quickly build one, and so I have like an hour to do this, so if I can build an analyzer in front of you guys in less than an hour, that shows it's pretty doable to do. And the last thing we're going to do is explore the analyzer ecosystem that exists today and see what analyzers people have put out there, how you can use them on your own teams to enforce code quality. So what is Roslyn? Roslyn is the code name for the .NET compiler platform project, which probably also makes no sense. But basically what it is we took the original C# and Visual Basic compilers that were written in native code, and we completely rewrote it in managed code. So we did this huge re-architecture project. And one thing that we started this 8 years ago, and it finally shipped just over a year ago with Visual Studio 2015. So something we worked on for a very long time, and it just shipped. And then it's also actually been open source for 2 years now. And so if you go to our GitHub, which you can get at roslyn.io, you can see the whole compiler code is out there in the open for anyone to read for how C# and Visual Basic are compiled. And so along with being open source, we also embraced open product development, which means all of our bug tracking, all of our code reviews, everything is done out there in the open. And in addition to this, we also do open language design. So all of our design for what comes in the next version of C# and the next version of Visual Basic is done on GitHub for everyone to see. So this is for C# 7. If you go to our GitHub, this is one of our proposals for introducing tuples. You can see Mads Torgersen, who's our main language designer. He types up a bunch of notes, puts them out from these language design meetings. And if you look closely, you can see that 74 people from the community were involved in this thread, and it has almost 500 comments on just the language design for tuples. This is just one of the proposals, so it just goes to show how involved people are in this language discussion, and it's just pretty cool that you can read all of this and follow language design in the open now. So why did we do this? Like, why Roslyn? Why spend all the time, like 8 years, completely rewriting the compiler? There's really two main reasons we did it. The first was it was going to let us write features faster. So if any of you have followed Visual Studio 2015, you may have realized that every 3 months or so, a new update came out. And updates didn't just have bugs in them. They had tons of new features in them. So this is part of like Microsoft and Visual Studio. We're trying to be more agile and deliver more often. And so we need to be able to keep up with that kind of cadence. And so we need to be able to write these things faster. Again, with C# 6, C# 6 was delivered with Visual Studio 2015 just over a year ago. And now here we are in 2016, and C# 7 is almost done. And so that just goes to show that never would have been possible in the old compiler, but now that we have it rewritten and managed code, this is something we can now do. And the second thing is what we're going to spend the majority of this talk talking about is we decided to re-architecture everything so we could put an open source API surface on top of the compiler. And so what this does is it lets anyone in the community write a code-focused tool or technology that has a deep understanding of C# or Visual Basic. So if you want to write a meta-programming tool, you now have all the APIs for the syntax tree, the semantic model, et cetera, to be able to write these. Or if you want to write your own scripting engine for C#, if you want to write an interactive playground for C# or like a code generator program, all of these things you can now do because we have this API surface that anyone can use. So for the rest of the talk, we're just going to dig into those two reasons. So the first one, I'm just going to sneak peek into what's coming in C# 7. If you really want to go deeper into it, come to the talk on Friday. That's where I'll talk about everything what's new in Visual Studio and languages. But so as part of Roslyn, we can now write these things faster. And so C# 7 doesn't have, it has some syntactic sugar things, but they're really involved syntactic sugar things. So for example, tuples, which allow you to return multiple values from a method. So instead of having to juggle out parameters, you can now use something called a tuple to return multiple values from a method. So you can see here, I have a method called tally, and it basically is returning 2 ints. And I don't have a single out parameter involved. And so that's something that came in C#7. We also have pattern matching, which is going to let you test expressions on both the shape and their contents. So you can see here I have a switch on expression v. And on this, you can see that I'm seeing if v is an int, do something. If it's an object array, do something else. And so I'm checking the shape of this. You can also, in this same thing, check the value, but it's not in this example. You can name your patterns. So if v is an int, call it I, and then you can see in the rest of, I have a pointer on this somewhere. Oh, yes. So if v is an int, call it I, and then you can reference it down here. Same with if you have the object array, you can call it L, and then you can do things with it down here. Does that make sense? Everyone got that? All right. And the last thing was local functions. So local functions basically let you nest helper functions inside of a main or a primary method. So this basically the value is just to help clean up classes. It also lets you get rid of a lot of parameters. So you don't have to, in a helper method, you have to pass it a lot of things from the initial method, and now you can just get rid of that completely because they're all accessible within that method. So you can see here, tally is actually nested inside the main method in this example. So all these features wouldn't have been possible to do in the old version of the compiler, but now that we have Roslyn, we're able to just churn out these language features, which is pretty awesome. And so for the remainder of the time, we're actually talking about live code analysis and what this helps us do. So live code analysis basically identifies errors in your code the moment you introduce them. And so so we've had code analysis in Visual Studio forever, like 10 years or something, but it always depended on when you built. So you wouldn't see them until you built, and then they would all surface up, and you'd be like, oh my God, I have to go through all of these. So what we're trying to do is actually tighten up this feedback cycle so you're getting the errors in your face as you're typing. And so that's what Roslyn lets us do. It was designed with this in mind. And so we also put an extension point in it, so now anyone can write a custom analyzer to do this for you. So you don't have to depend on our team to write whatever you want. So if you think, oh, no method should be longer than 100 lines, you can write that analyzer and publish it and distribute it on your team without ever having to go through us. So again, analyzers help you identify errors and provide fixes in your code as you type, and that is where the value of all of this is coming from. So we can sit and talk about this all day, but we might as well just show it in practice. All right, so in this example, if you look closely, you're going to see there's various different things going on here. So for example, I can see there's a green squiggle here. And if I zoom in, a green squiggle basically means there's a compiler warning traditionally. But with analyzers, it just means a warning in general. And this is actually producing the diagnostic that this variable is never used. So args is never used, and it's highlighting this for me. So this is one of the uses of analyzers where you can use it to help figure out where you need to go next as you're typing code. So for example, this is telling me I never use args. Maybe I realized I needed to use that, and I didn't use it anywhere, and so now I know the next thing I need to do when implementing something in this class or in this file is that I need to use args. Another thing is, for example, you can see up here, it looks like there's a lot of faded out code. Can you all tell that it's faded from out there? And so it turns out if you hover over this, it's saying the using directive is unnecessary. The using directive is unnecessary. And then you can also see that there's this little light bulb thing that pops up. This little smart tag basically just indicates that there is a fix available here. So anytime there's a code fix, you're going to see this light bulb. It also comes up for refactoring. So if you want to refactor something, you'll also get a light bulb. You can also trigger it with control dot, which is like a much easier way of doing this. And then you can see as you do this, we tell you what the code fix is. So this is the name of the code fix. It's going to remove the unnecessary usings. And then what Roslyn, we've been able to do with it is we can actually generate a live code preview of what this change is going to do. So you can see here, oh, that didn't work. Well, you can see here that it's basically a code diff of what's going to happen when you apply this fix. So just like in source control, where red is the stuff that's going away, green is what's coming in, this is going to show that all of these usings are going to disappear. So I can just click enter, and it removes them all. If you also looked closely when we did this, you can actually do this across your document, project, or solution as well. So if you want to if you're done and you want to merge all your code in, or you want to submit your pull request, before you actually make that PR, you can then clean up everything just by going here. Cool. So that's another use. If we look here, you might see int is squiggled, and you might be like, why? And so if we drill in, it says use a var instead of explicit type, which might have you all being like, say, what? Like, why? Because code style is kind of an iffy subject. But if we zoom in here, we can see that you can also enforce code style on your team using analyzers. So if you're a big stickler for code style and you believe everyone should use var and not the explicit type ever, you can make it an error in your code. So that's what I've done here. There was a red squiggle under int, which means it's going to break your build if you have this error. And so if you're really a stickler for this, you can enforce all your code style rules on your team as errors, so no one can even build their code if they violate your style rules. Yeah?
Are these actually the extensions you were talking about, like building your own extensions to code analysis, like you do this thing?
Right, okay, so the question was, are these things that I'm showing you right now, are they third party or are they built in? Is that correct? All right, so some of them are built in and some of them are third party. So that's what I was going to show in this example. Is if I come down to the error list, you can see down here. So compiler is one from our team, but all the rest, you can see that they come from these various tools. So ones like Refactoring Essentials, that's a V6 installed through the gallery. Codecracker is also a V6, and so is C# Essentials. And so these are just third-party ones. But there are a ton that are also built into Visual Studio, which I talk about all those on Friday, but I can show you some at the end if we have time, if you want to see those. But the code style one is built in. We have a series of code style ones that are all built in that you can customize how you want them enforced. So again, live code preview, I can fix this now to be like that. You can also see that they're all in the error list, and so you can just go F8, like if you press F8, that takes you through everything in the error list. So if you're one of those people that likes to type and at the end of the day you want to go back through, you can just go down to the error list and see all the errors and things that you have. The next thing is if you look super closely in this build, the color didn't get quite right, but there are faded gray dots under the 100 here. Can you see that, kind of? All right, so it's going to be darker later, but for now, that's what it looks like. That suggests a suggestion. So an error breaks your build. A warning is pretty in your face with the green squiggle, and a lot of people have enforced warnings as errors enabled, and so that's sometimes a bit harsh for what you want to do. Sometimes you just want to nudge a junior developer towards a best practice, or maybe you don't want your code style to be so in your face, you just want it to be a suggestion. And so that's what this faded dot is supposed to do. It's supposed to be a suggestion, just to let you know as you're typing that maybe there's something else you can do here. So for example, in this one, it's telling me maybe I should compute this expression instead of actually doing that. You can also use these to teach things. So for example, here, my colleague made an extension that helps you move from C#5 to C#6. So this is telling me, oh, you have a method that only has a single line, so you can just make this an expression body member. And so you can see here, I can just make this an expression body member and apply it. So are we all following along? All right. So these are just various ways that you can use analyzers today. So with that, we'll go back. So now that we know what they look like, we can talk a little bit more about them. So analyzers all have something called a severity, and that controls how they appear in the editor. So again, an error will be a red squiggle, and that will break your build no matter what. A warning is the green squiggle, and it will only break your build if you have warnings as errors on. A suggestion is supposed to be more of a lightweight thing. It's not going to break your build, but it's just like a gentle hint as you're writing code. And then you can set it to none, which will do nothing. in your editor. It won't display anything. It won't show up in the error list. It's just like if you download a package, analyzer package, and you don't like some of the rules, you can just put them all to none, and that will turn them all off. So I kind of mentioned this before, but analyzers can actually be packaged in 2 different ways to be distributed. The first is a V6. A V6 will be through the extension gallery. Basically, a V6 will not work on your CI or from the command line, though. It only works on your instance of Visual Studio. So it's tied to Visual Studio, but the benefit is that it will apply to every project in your Visual Studio that you have. So if you want to apply something to everything in there, you can do it, but it'll be local to you. NuGet, on the other hand, it's per project, so you have to install the NuGet for every project that you want it to apply to. But it will run on your CI and from the command line, and it can be used as like a team enforcement. So we actually recommend people write these as NuGet, but you can do it as a V6 if it's something you want to do. And so just to recap, there's various ways that you can use an analyzer. So the traditional one is you can just use it to find errors before you build, but you can use it to enforce code style. We have something called a code-aware library, where it's if you're a library author and you realize people aren't using your library the way that you expected. For example, if you're like the Azure SDK and you realize a lot of people are using datetime now, which can cause issues between like the local time on your machine and the actual server time, and you never want people to use datetime now, and you realize a ton of people are doing it and running into issues, you can make a NuGet package full of analyzers for best practices for your library. And then that way, anytime anyone types datetime now, it's going to squiggle it, and you can make it an error by default, and then provide a fix for how they should actually use your library. So that's something that a lot of people do that's pretty helpful. And lastly, you can use it as an educational tool. So like my colleague wrote it to help people move to C#6. And we had a bunch of interns actually who wrote a meta-analyzer, which was an analyzer that teaches you how to write an analyzer. So pretty cool, but also pretty out there. But it just shows that there's so many different ways that you can leverage these things to teach people. All right, so now let's actually go into what the APIs are that are part of Roslyn. So if you look at the left-hand column for you guys, first, there's a syntax tree, which basically is a high-fidelity representation of your code. So this includes comments, white space, like end of line, trivia, like the whole nitty-gritty is all in there in the syntax tree. And then you have the semantic model, which basically contains all the symbolic information. So if you want to know what the name of a parameter is or what type an array is, you have to query the semantic model for this information. So that's how it works today. Which it's really great to have this model when you have a syntax tree that contains all this information at high granularity, because if you want to write like a formatting tool, for example, you need to know where all the white space is. That's super important. Or if you're writing a refactoring, for example, you need to know where all the white space is for that as well, so that you're adhering to where they have tabs, where they have braces, etc. But sometimes it's kind of a double-edged sword, because sometimes, like an if statement is just an if statement. I don't have to think about the different shapes of an if statement. Or, for example, in the example we're going to do, we're going to look at every time you new up a zero-length array, and there's multiple ways to do this in C#. And I don't want to have to think about all the different ways to do this. Like sometimes, like when you create an array, it's just an array creation expression. I don't want to think about the various different ways to do it. And so that's why the natural progression of our API is to now include something called IOperation. And so IOperation provides this extra layer of abstraction over the semantic model and syntax tree. So it provides more semantic information over the syntax tree. And actually, it's so abstract that not only does it go over shapes within a language, but it's so abstract that it goes across languages. So you can write a single analyzer and IOperation for C#, and it will automatically work for Visual Basic. So if you have both, though, if you're on a team or you're using both languages, you can now write one analyzer that will work with both. Yeah, and so that's what those do. And the syntax generator API basically lets you generate syntax language agnostically. So the other way is with syntax factory, but the syntax generator, when we write our code fix, the way that code fix works is you have to actually write the syntax or make the syntax tree for the fix. And so we do this with the syntax generator API. So how are we going to write one of these? So again, what I said what we're going to do is we're going to find everywhere where you knew up a zero-length array, and we're going to find it, and we're going to squiggle it, and then when you press Control dot, we're basically going to offer the fix to now use array.empty instead. So array.empty was introduced in the 4.6 version of the framework, and it basically is just to help reduce the number of allocations. So if you are newing up zero-length arrays everywhere, it's an allocation for every time you do that. But if you use array.empty, that's just a single one that you can always point to instead. And so really briefly, before we actually go code this, the diagnostic is the part that finds where the error is in your code and squiggles it. That's called the diagnostic. And the code fix is the thing that comes in this light bulb menu. All right, back to the code. So let's go back over here. We are super nice, and we actually provide a template for you guys to actually write these. So here's the diagnostic template. You can see it looks a little intimidating at first until you realize that all of this is boilerplate, essentially. So it's basically what's the title of the title that you want to appear in your fix, the message format, and the description. And so we can actually change these in the resources file. So to prove that this is real, I can say like MS Ignite New Zealand, don't create a zero-length array. Woo! And so we'll just save that. So again, just a bunch of boilerplate up here. And then you can see that we are going to define a rule. And the rule just contains all of these titles, message format, et cetera. And it's also where we can set the default severity of our analyzer. And so, like, for example, you can see you can make error, hidden, info, or warning. So we're just going to keep it as a warning. And then really the only thing that matters here is this initialize method. And so what initialize is doing, it's letting you register a callback that's going to happen whenever the live code analysis hits a certain token or symbol or whatever we say it's going to be. So that's all we have to do. But like, what does this look like? Where do we begin? Like, I don't know what we're doing. All right, like I don't even know how to find out if it's a zero-length array, right? So what we're going to do is right now, I'm pressed F5, and what F5 is going to do when we're in this template is it's going to open a new instance of Visual Studio with a v6 installed of the analyzer that we're writing right here. So what that's going to do is it's going to let us test our stuff. But for now, we're just going to open up what our test project is so that we can dig into what the syntax is. So something that you're going to see here on the left is something called the syntax visualizer. It's part of the .NET Compiler Platform SDK, I believe is the name of it. And what that does is it lets you actually see live what the syntax is. So for example, I can select this expression, and then you can see it's highlighted over here, and I can see that's an array creation expression. And I can drop down into the different elements of it. And if you find this hard to read, which I find it kind of hard to follow, you can view the directed syntax graph of it instead. And when you do that, then, the zooming on surface not working. There we go, okay. Then you can see that this is an array creation expression. It has an array type. And you can see that we're going to find out that it's a zero-length array by looking under the array rank specifier at this numeric literal expression, which would be all fine and dandy if that were the only way to zero up an array. But we also have this syntax, which if now I open up the directed syntax graph for that, I can see it's entirely different. And so now I would have to check an entirely different way to see if the array creation that we come across has a zero length this way. So then I have to think of two different ways to do this, but really at the root, they're just array creation expressions. So this is a perfect opportunity to use that IOperation API that has that extra layer of abstraction where now I don't have to think about that there's two different shapes for newing up a zero-length array. To me, they're all going to be the same. And so to learn more about IOperation, we just have to go to the source code because documentation is hard. But anyways, so you can see here that we have, also source.roslyn.io is like this kind of interactive way to navigate our source code in Roslyn. So I strongly recommend you use this. And so you can see here, I have the interface IOperation. It has a thing called a kind, which is what our code analysis is looking for to find something of that kind. It has a syntax, it has a type, and it has a constant value. So if we look at the different kinds, we want to find one that's like an array creation. And sure enough, there's an array creation expression. Now if we go into this, we can see that it has an element type, which just gives you the type of the array, which is going to be really helpful when we write the fix, where we have that generic, and we need to know what the generic type is that we're putting in. So we'll just lock that away for later. And you can see there's something called dimension sizes, which is where we're going to find out if this is a zero-length array or not. And that's all we have to do. We don't have to deal with anything else. It's abstracted this array creation expression to just these 3 different things. And now we're good to go. So now, come back here. Let me just close out of this one because we don't need it anymore. Okay. So before we start registering our main callback, we actually have to do another one because we don't actually want to offer this fix unless they have the 4.6 version of the framework, because it would be really a bummer to squiggle something and say, hey, use array.empty, and then when they use the fix, they can't actually use it because they're on the wrong version of the framework. That's poor user experience. So the first thing we're going to do is you can see as we type, you can see as we are typing that there are a ton of register actions available to us here. So can you all see those? So there's tons of different ones, and this is basically at what point are you going to register this callback. So we want to actually start with the compilation, the start of the compilation. So when we start the compilation, before we do anything, we want to make sure that they have the 4.6 version of the framework. So also my IntelliSense dies in this build, so oh yeah, it just died. Okay, good thing I know this stuff. Okay, so we go here, and then the first thing we want to do is we want to find the array type, and then we're going to see if the array type in here has a member called empty, and that's how we're going to check if we're on the 4.6 version. So we can dot into here, and if we dot it in, we would see that there's something called a compilation, so we can access the compilation, and then from there we can get type by metadata name, and then when we do that, we're just going to find system.array, and then once we have system.array, we're now going to see if the array type, or see if it has the member, empty. So get members, empty. And so if this exists, then now we can do the real work and see if we ever find an array creation expression, we're going to register a callback. So we go to our start context, and we're going to register something called an operation action, because we're going to wait for us to find the operation instead of the actual symbol or node, because we're doing this higher level of abstraction. So we're just going to name our callback something like, I don't know, analyze array creation. And then we're going to put in what our operation kind is that we're looking for. So it's going to be an array creation expression. Cool. And so basically what we've done is we just said, whenever our live code analysis finds an array creation expression, we're going to call analyze array creation. And so now we just have to write analyze array creation. So I just used control dot there to generate the method. Another thing in Visual Studio 2015 and above. Oops. So I'm just going to rename this context for consistency's sake. And so now in here, I want to get my operation, but I really just want my array creation expression. So array creation, I'm going to cast it as that array creation expression. I know I can do this safely because we're only passing in things that are array creation expressions. And then our context has an operation. And then all we want to do here now is check if it's a single dimension array and if size is 0. So that's all we have left to do. And then we're done with this diagnostic. So first we're going to say, does array creation. So we can now access the dimension sizes. So dimension sizes, see if the length is 1, see if it's a single length array. If it is, then we're going to go in dimension sizes, and we're going to see we're going to access that constant value we saw earlier, see if it has a value. And if it does, then we're going to pull out the dimension size. So, because I can't type this anymore, dimension, sizes, constant value, grab its value. So now we have our dimensions. Now we're just going to do if dim is 0, and then we're just going to report our diagnostic. But you can see we already have a diagnostic that popped up. And if we zoom in a little bit, it's telling us that dim is actually an object and not an int, so we can't actually do this, which is a bummer. So we have to do the typical, see if it's actually an int, and if it is, cast it, blah, blah, blah. Which this should look familiar if we were paying attention earlier, right? Because we're checking the shape as well as the value of something, which sounds a little bit like pattern matching, maybe. Yeah, all right. So we can just delete all this. C#7, woo! So C#7 pattern matching lets us write something like this. So dim is 0, and that's automatically going to do the cast and the null check for us and check that shape and the value of the expression, which this looks a lot nicer. So cool. And so now we're just going to create our diagnostic. So diagnostic, create. So it's going to take that rule that we defined up above, remember, where we had all the kind of defaults that we set for it. And then the next thing we need is a location. So by the location, it means the span. So we're trying to figure out where exactly in this document are we putting the squiggle. And so that's all that means. And so to get this, we actually need to know exactly where the syntax is. But right now we have this abstract operation thing. But luckily, we saw earlier that you can actually get the syntax from the operation. So we're going to have our array creation. We're going to grab its syntax, and then the syntax has a get location command. And then we good. And then all we have to do is report our diagnostic. So that was like maybe 15 lines of real code, if not less, to do all of this. So now, to prove to you that worked, we're going to F5. And again, when we F5, it's going to start the new instance of Visual Studio with a v6 of this analyzer installed. So when we open up that same project, we expect to see those two different ways of newing up a zero-length array. We expect to see both of them squiggled with a green squiggle because I made it a warning. So let's open this up, moment of truth. And so you wait a second for the analysis to run, and sure enough, we got the two green squiggles because our analyzers are now running. And so if I hover over, it's saying MS Ignite New Zealand, don't create a zero-length array. Does everyone see that? Woohoo! And so it did both of them too, because I-operation allows us to abstract over the shapes within a language as well. So the next thing we want to do is write the code fix. So I should have put I'm pretty sure I put a breakpoint in here. Yep, okay, cool. So now we write the code fix. So you can see I'm in the code fix provider file. So this is another part of the template for analyzers, where now you can write the code fix. So again, it has a bunch of boilerplate at the top. And the really only thing you need to know is that we have now a register code fix method, which is where we're going to write our callback for this. So if you have more than one diagnostic, you have to do different things for each one, but we only have one. And then we just have this use array empty. So all we're going to do in this use array empty is we're going to find where our syntax is in the tree that has this array creation expression. Then we're going to use that generator API and create the new syntax, so the array.empty. Then we're going to swap them and then create a new document, or refresh our document with this new syntax array, syntax tree, and then return it. And then we're done. So we're just finding where the array creation expression is in the tree. We're going to create our new little subtree, and then we're going to swap them. And that's all that goes into a fix. But we might realize, I need to disable this, that we don't actually know what the syntax of an array.empty expression is. So we're just going to go back to our example, and we're going to select this and see what it is. So if I look at the directed syntax graph, we can see, that it's at its root an invocation expression that has a member access expression that's going to have a type and then it's going to have a generic, and then we need a type for that generic. Does that make sense to everyone? All right, so that is what we need to build now. So let me put my breakpoint back in. Come back here and let's hit it. Unfortunately, I don't think edit and continue is working super well in this build, but we'll see if we can get something to work. So we're going to use this generator API to now create our syntax. So I'm going to kind of like reverse do it. So we know that we need an invocation expression. So we're going to use our generator, and then we just type invocate. Oh, I killed it. Okay, hold on. Oops. It's much easier to do this when you have the IntelliSense for it, because it goes way faster. Okay. Generate that. Okay. Invocation expression. Woohoo, that was easy. Invocation expression, we said that had a member access expression as part of it. So we're just going to do member access. Then we're going to generate. So again, I'm just going to use analyzers to help me write this whole thing. So there's a thing called generate local, because I referenced something that didn't exist yet. So I can just do this, and it's going to create that. I want this to be var. And so a member access expression. So now we're going to do generator.member access expression. And so that's going to take our array type expression and our generic generic expression. And so again, we're going to use control dot to help me auto-generate these. So just generating locals for them. And then from here, we're going to do generator.type expression. And then to get that array type, we're going to do exactly the same thing that we did in the diagnostic, where we're going to do, we're going to get our compilation. So our compilation is in our semantic model. We're going to grab that compilation. And then from this, we're going to do get type by metadata name and get system.array. And so now we have our array type. And then all we need is our generic. So it's generator.generic name. And then this is going to be empty, is the string we put in here. And then we need that type for the generic, which, if we remember, going back to this, that we had the element type right here. And that was going to give us the type of the array from the operation. And so we just come back over here, and then we're just going to do array operation dot element type. And then as you're building this, edit and continue is like so broken in this thing, I can't actually show it to you, but I left it up from a time that did work. You can just type toString on any of these things to actually see the syntax that you're writing. So here, let's do the pointer. You see here, I have this generic name thing that I just created, and I did toString on it, and you can see that it did empty of string. So we know that we created the syntax correctly. And so you can do it in every single thing. So I often build these. Oh, my necklace is hitting the mic. Sorry. Okay. I usually create the entire thing in the immediate window, so I can see that I built the syntax correctly. And then I actually just put the code back up above. Cool. So now that we've created our little subtree, we actually need to do the swap now. So we're going to create a new root, and our new root is going to be the root, and we're going to replace a node. And so we're going to replace the array creation node, which is that array creation expression. And we're going to swap it with this new invocation expression that we just built. And then we're going to create a new document that has the new root. So document with, I believe it's with syntax root, new root. And then we're just going to return this new one instead. And so now, disable this, continue. If I go back over here and I do this, press control dot, it's going to tell me to use array.empty, and you can see the code preview that has the whole thing for me. So again, that was like less than 20 lines of code to write that whole thing. And just for some extra fanfare, why not? I have a Visual Basic file in here to demonstrate the I-operation abstract so far. So if I wait for the analysis to run, it found this empty car array. And then if I do control dot, it tells me use array.empty and puts it in the VB syntax for me. And that's because I use that syntax generator API. And so it generated the syntax in VB for me. So pretty gnarly stuff, eh? Do you all say gnarly in New Zealand? Is it wicked? I don't know. I don't know what it is. I haven't been around long enough to pick up the slang. But okay, so that just goes to show what you can do with analyzers and how you can extend them like that. So, cool. So does anyone have any questions on, yeah, in the back? For the built-in rules, what's the best way to figure out why they're recommended? What do you mean? Oh, like why we're showing things as errors. So like, for example, the one in the earlier example I showed, that was putting the warning under args because you never use the variable. You just hover over it to see the message for why it is. Are you talking about the code style one?
Yeah, so for the, this one you just explained why we should be initializing the array in a certain way.
Mm-hmm.
As an end user, how do I know why I should be doing that?
Right, so we actually encourage, so what I should have done over here is when I told people in the message why they should be using it, so in the resources file, if I go here, instead of saying, oh, msignite, don't create a zero-length array everywhere, I should have put in here, newing up a zero-length array provides extra allocations, use array.empty of t to reduce the number of allocations in your code. Like I should have actually put a coherent and logical reason in there. But like, where's the fun in that? But yeah, so that's what we encourage authors to do, to like explain why things are. But not all analyzers are these kind of like best practice type of things or like actual errors. Like some of them, like that compute expression one where I had like the 100 minus 42, like you don't have to make that into 58. It was just a toggle kind of thing. And so you can write these analyzers that are more just like toggles that you can do. And in that case, like we make it so that anyone can configure how these things are done in the editor. So like for example, I didn't really want to show this because we're going to change it in the next version of Visual Studio, hopefully. But we have a rule set, and a rule set file has all the different analyzers. So for example, here is the code cracker package, and everything is set as a warning. That's because I did it on accident. But I can choose to make certain things different. I can say, oh, I don't want to see any of these. I can make them all none. I can make this one an error. I can make that a warning. I can make this info. And so you can change how they are all showing up in your editor. So the author just gets to set the default, but you as the ultimate end user get to choose how they actually are displayed inside of your editor. Does that make sense? Yeah, and so we have a rule set file right now that you can do. What we're hoping to do in Visual Studio next, which is the next version, or it's called 15, but that's confusing, is we want to use editor config. So editor config is an open source file format that currently has like 6 default formatting rules. And so we're working with them to extend it so that will work for code style analyzers. So you can basically, right now, I can show you code style. So you can see here. So these are all the code style rules that we have in Visual Studio today. And you can change how they're all enforced inside your editor. But we're going to abstract this all out into just a text file. And then in that text file, you can set all the severities and stuff like that. And it will travel with your code and your source control, as well as you can use them in your CI. And so that's the ultimate goal with this stuff. Cool. Did that answer your question? All right. So what analyzers are out there? So I showed you some of the ones that were built in, but there's also a ton that exist in the ecosystem today. We don't have a registry, which is like one spot where you could find all of these. Like there's not like a gallery of analyzers, unfortunately. Hopefully there will be one down the road. Right now we recommend you like type analyzer into NuGet.org or into the extension gallery as a workaround. And we haven't, as like Microsoft, as a company, we haven't actually endorsed a set of analyzers that's like, oh, these are the ones that you should install. So I'm just gonna like show you ones that I know exist, but it's not actually me saying, oh, use this one. Other than I can tell you use the FX Cop ones because we wrote those. So if you use FX Cop, they normally run on build. So we actually took the top set of ones that are used by people and we wrote them as analyzers. So that means as you're typing, you can now get squiggles for them, and where it makes sense, there's code fixes for them as well. So those are those. SonarLint, I'll just take you to these. SonarLint actually claims to have 80% of the ReSharper default analyzers made in this package. And so you can see all their different rules here on the left. And see all the different things about each of them. And so that's SonarLint. If I go back, there's StyleCop. So if you use StyleCop on your team, we have a guy in the community who I believe, I don't know if he wrote all of them himself, but he wrote a lot of them himself. So we can like dig into all of these StyleCop analyzers he wrote. If we just want to look at like readability rules, for example, you can see all the different rules. Oops. My mouse is traveling all over. You can see all the different rules that he's implemented here. And almost all of these are open source, so if you think they're missing, you can contribute. Yeah?
Are you expecting it to show up on the screen?
Oh, yeah. Oh, you couldn't see any of that? Nope. How do I show like the website on here? How do I get out of the presentation on here? I'm hitting escape. Oh, maybe I need to be in the presentation and hit escape. Did that work? Oh, yeah. Okay, cool. That still didn't work. Oh, okay, sorry. Okay, so if you go to StyleCop analyzers, you can see all the different ones that he has here. Thanks for pointing that out. I never would have noticed that. Okay, back over to the slides. I don't know how to keep going back and forth. That didn't work. Okay, instead we're just gonna, can we go over here and, okay, hold on. Exit this, close. Is this touch screen? No.
Windows K3.
No. Good thing I don't have that many slides, right? Okay, so I'll leave them up there and then I'll show them over here instead. So I can click on them over here more easily. Okay, so that was the StyleCop ones. The next ones are CodeCracker. So CodeCracker has a lot of VB and C# ones if you use VB. And so you can dig into all of their ones. Roslynator, this one's interesting. It's like a single guy wrote 80 analyzers and 140 refactorings. And he documented every single one, which I'm jealous. I wish I had done this. Okay, but so you can see every single refactoring he's written. And so, yeah, he shows you what all of them look like. You can turn them all on and off or whatever, but if you're super into refactorings, like he has a lot of them out there. And so if you think you're missing one, maybe he's already written one that you can use. Refactoring Essentials also has a lot of refactorings. So you can also, there's an analyzer template and a refactoring template that you can do. So you can also write your own refactoring with the same APIs. So if we go here, you can see all the refactorings. They also documented them nicely, which I'm jealous. So here's some of those. All the refactorings they've written. They actually have more, I believe. I just have to click this for the complete list so you can see all the ones that they've written. So you can see that there's a lot of these out there, and probably one of the ones that you need is here somewhere. And the last one that's kind of interesting is one called GCOP, which it's some like UK firm that just wrote their own, and they're like, this is our team's set of rules, and they just put them out there. And so if you want to do what Geeks Limited does, like, you can download GCOP and have their rules. And so we think it would be pretty cool if like a bunch of different companies like advertise and endorse their own, and we're like, oh, you could have the XYZ companies analyze the rules, and that would be pretty neat. So yeah. Those are the analyzers that exist today, or these are the ones that I've been able to easily find on NuGet.org and on the extension gallery. So, write an analyzer. Guys, it was pretty easy. It was like 20 lines of code. Do it. It's really fun, actually. So, the documentation is kind of meh, which is why we have this getting started kind of thing. So we've done tons of different talks and stuff on this, and we've written tutorials, so hopefully some of those will help if you found this talk slightly confusing. And then explore what's in the ecosystem today. So if you think that we're not providing something that you want, someone probably has already, and if they haven't, you're a great open source contributor if you contribute to one of those, or you can start your own and have that as well. And then if you are interested in what's new in C#6 and C#7 and VB14 and VB15, and what's different between Visual Studio 2015 and Visual Studio 15, which is the next version, I'm giving a talk at 9 a.m. on Friday, if you want to come to that. And does anyone have any questions? Yeah. Yeah, I'll post it somewhere. Yeah, I'll ask like Reagan to send it out somewhere that it's up. Oh yeah, it might be on. Yeah, the recording will be on Channel 9 at some point. The slides themselves, I can post them online somewhere for you guys. Yes.
Towards the beginning there, I saw you jump to a file quickly with a little data log. This is a little bit of a size. That's not really lost. So how did you do that? Because that's a lot like how Resharp does it.
Oh, yeah. Oh, you're jumping ahead. Okay, this is for the talk on Friday. Yeah, so you were wondering, okay, you might get a laugh at this. It's Control-T. If you press Control-T, you can type any file name, type, name, member, symbol. So I typed like code fix.
Nice with Resharper, or do they kind of butt heads a bit?
What do you mean?
If you install Resharper while you've got all this going, what happens?
Yeah, it all works alongside Resharper. Yeah, you might see a lot more suggestions. So actually, yeah, so they work. So they built on top of our light bulbs. So they like hack into ours, and so it might get like really long. Yeah, yeah. Oh yeah. So the question was, does this play nicely with Resharper? And then that was the answer. Okay. Yeah.
Could we potentially export rules from Resharper? And can you, in your CI, could you cause Resharper to break a build back to Roslyn? Could you do that with Resharper?
Right. So the question was, can we extract rules from Resharper into Roslyn analyzers, and then can we also take Resharper rules and make them break the CI? Right. All right. So unfortunately, Resharper does not use Roslyn. So it's not actually built on Roslyn, so it can't actually break your build. So you have to like be the compiler to do that. But it does look like people are doing initiatives to actually, like the SonarLint people took 80% of the Resharper diagnostics and converted them to analyzers. So it seems like there's movements for that. Also, on the Friday talk, you'll see that we're doing a lot of refactoring and stuff that have overlap with Resharper as well. So yeah. So those ones, anything, yeah, so any Roslyn analyzer will be able to break the build. Anything else that's third-party extension will not be able to. Yeah. Yes?
Sorry, the Roslyn was introduced in 2015, right?
Yes.
Right? I've noticed a significant memory consumption trend like between the 2013 version and 2015 version. Is this likely to be contributing to it, or is it?
Right. Okay, so he said he's noticed a lot of memory has been used when he went from 2013 to 2015 because of Roslyn. We are aware of some of those things, so we kind of assumed people would have, so Roslyn's pretty big. We assumed people would have like pretty big machines that could handle it. But what we realized was in Visual Studio 2015, are you on update 3? Because on update 3, we did a ton of work to make it more performant. So for example, we used to load basically in your solution, we had something called full solution analysis. So we would run all this live analysis on your entire solution and report all the errors in your entire solution, which is great because we're giving you all the errors everywhere. But if you have a massive solution and we're constantly running analysis over that entire solution, like that can be very memory intensive. So we have a toggle now that says enable or disable full solution analysis, and so it's off by default in update 3. So it should not affect your performance that much. And then in Visual Studio 15 or Visual Studio Next, we're pulling it all out of process. So all live code analysis will be out of process, so it should never interfere with lagging or typing or anything in Visual Studio. Yeah. Yes?
Can you disable the page?
Can you say that again?
Can you disable the code analysis in like one particular file? Like if you have a file that's different than the others and you don't want it to run? For the whole project.
Right, so the question was, can you control which files have the code analysis run on them? And the way it stands now, no, but we're hoping to have editor config, and editor config is by directory. So if you have, for example, all your legacy code base, so you never want an analyzer to run on, you can have like an editor config file that has every single analyzer turned off for everything in that directory, and then you'll be able to control it that way. So that will be coming in the next version of Visual Studio. Yeah. Anything else?
When you debug to start looking at the syntax tree, can you debug from that new instance of Visual Studio? It's a bit of a silly question, but can you just keep going?
Oh, okay. So the question is, can you like, when I debugged and got the new instance of Visual Studio, could you then write an analyzer in there and debug a new instance of Visual Studio from there? I have never tried that, but I'm assuming, yeah, it's possibly possible. Yeah. Any last questions? Cool. Well, thank you all for coming. Enjoy the rest of your day, and hopefully see you Friday.